Welcome to another episode of Space Science with Python. As I said the last time, we are now switching between a coding part and a space science part. And today we are now again coding a little bit, but also we will talk a little bit about near-Earth objects and also what kind of classes and types are in there. So this is the task of today's session. We will classify our NEO-orbit data that we fetched last time and stored them in the SQLite database, and will assign them a certain class. And this database here is also in the GitHub repository. So if you are making a pull, you will find all the data here: the name, the designation number with the semi-major axis, eccentricity, argument of periapsis, and so on and so forth. And now these are a lot of values. We have around almost 30,000 NEOs in the database. And today we will talk about NEO classes. Now, before we talk, let's go into some links. I will also share in the description call it NEO basics. So we have a website from the JPL from NASA, the Center of Near-Earth Object Studies, and the NEOCC, the Near-Earth Object Coordination Center by ESA. And let's have a quick look about what this session today is all about. So this small table here on the right-hand side summarizes it quite well, what we will do. So we have different classes in our database and or in our NEO population. Then the near-Earth comets, near-Earth asteroids. Okay, let's skip these classes. I would like to talk more about objects that are defined in a more astro-dynamical way. And for this we have the Atiras, Atens, Apollos, and Amors. And well, they are defined based on the first object that has been found in this category, like the Atira, here 2062 Aten, Apollo, and so on. And you see here the corresponding orbital element definition range. So instead of now going through all these things here, let's have a look at a picture. The picture says more than 1,000 words. And we see here, especially the Apollos and the Atens, they are the only categories that are or that can cross our home planet. So of course, if this orbit is highly inclined, so if the Aten object is highly inclined, let's say 90 degrees, then of course it may has a property range that it's not hitting our planet at all. Same applies also for the Apollo. So you see here the Apollos are, they have a very wide object orbit here. The Atens are more eccentric, and the Amors and the Atiras, they are not crossing our home planet at all. So the Amors, they are basically revolving between 1 AU and 1.3 AU, so they are not crossing us, while the Atiras, they are within the Earth's orbit. And we do not know a lot of Atiras. We will take a look later or in a moment about this object here, 163693 Atira, and we did not observe a lot of them or discover them because, well, they are very close to the sun, so you can only observe them during dusk or dawn, and it's a little bit difficult from an observational point to observe these objects. I think we have already also an object that is within the Venus orbit. I'm not 100% sure, but the database will say it. So we will take a look at the data, the statistics in our next session. So we will see whether there's also an inner Venus near-Earth object. Well, anyway, here the link, I will provide you the link so you can take a look about the NEO basics. And this is the idea of today's session. We will use this definition range here to assign each object in our database the class Amor, Apollo, Aten, or Atira. We have also here now the NEOCC webpage with way more information, so feel free to go through it. I have to say a small interesting fact is the small gallery here on the bottom, because last time I said that I actually worked on the near-Earth object topic, and while I was going through the small gallery, I found some images, and I knew that I knew them because here you see, for example, and all the NEO positions. Oh, it's now a gallery going automatically through. So the NEO positions on the 1st of July 2012. So we had there only like, I don't know, 10,000 NEOs. And it was actually made by me. So this was during my intern time, trainee time at ESA. And you see it's very, very crowded. So here is the Mars orbit, and please stop. And here is the Earth orbit. But we will create this kind of these figures later in our sessions. So we will use, again, visvis and matplotlib to visualize all the NEOs so that you can really reproduce this kind of figure, and also creating a more recent one, you know, that is, yeah, now 10 years older. You see also here the word Atira was not in there. It was inner Earth objects. So yeah, at this point, the white dots, yeah, we see only a few of them. So maybe 10 or 12 or so, if I recall this correctly. Now, about the inner Earth object, let's have a look at the Atira. And Atira is a quite interesting object. So we see here from the now, unfortunately, out of service observatory Arecibo Observatory. It was a huge radar observatory that observed Atira. Here now an image from, or a small video from January 2017. And the funny thing is you see here the small dot. Well, this is not an error or something. Actually, this object is a binary object. So we have a major body, Atira itself, and a small moon that is revolving around Atira. So a binary object, quite interesting world. Would be nice to see it sometime with an actual mission. Let's go to the coding part. Now, today is a little bit quite simple, but I would like to introduce some new concepts a little bit. You have to be always a little bit careful with Jupyter notebooks. So in Jupyter notebooks, they lead you to work or code in a very chaotic way. So you can execute cells, you can re-execute the cell afterwards or before and so on. And sometimes it's not very straightforward. So it's really good, of course, for data science, for use cases or for some explorative analytics. But if you're creating some kind of product, Jupyter Notebook is not the way to go. So always try to create some kind of library. And when you create a library, there are certain best practices using tests, using coding standards enforced by, for example, PyLint or Flake 8, using maybe also static types, writing a proper documentation that follows a certain standard, and so on and so forth. So there are certain CI/CD tools that can be implemented, for example, in GitHub Actions, but yeah, we will not use it here in Jupyter Notebook. There's also a tool for Jupyter Notebooks. I will show this in the future when we will also talk a little bit more about how to create also sustainable code, even sustainable Jupyter Notebooks. But today we will start with a gentle introduction and some standards, let's say. We will not use any tools to really enforce it, but I would like to give you the idea of the concepts that I would like to show today. First of all, we have to import, of course, our modules. We connect to our NeoDice database, and then we have here our Neo classes. And you see here, before we go in the top part of the function requires the semi-major axis, the perihelion, and the aphelion. And these are the definition ranges that are defined here in the Neo Basics page. Yeah? So simply as a Python code. So if this requirement is fulfilled as an Amor, Apollo, Aten, or Atira, or maybe other, if you have if you want to type your own values and it doesn't fit in any category, then it's simply classified as other. And it's just it returns at the end then a class. And you see that here on the very top, the values are the input, the semi-major axis, and so on. And we are also assigning them really a type. So we expect float. It could also be an integer, but let's stick with the float. And the output of the function here, indicated with a small arrow, is a string. So the string is here Amor, Apollo, Aten, and so on. Now, if you would run some static type analysis and you would write here, for example, not other, but like the value 0, an integer, an arrow would be spawned and would indicate that, hey, maybe here at this point, it's not a string, it's more like an integer. Also the documentation, we have here a small text that explains what the function does, the parameters, and also what is being returned. Also maybe some references. This is the NumPy standard. There are also other standards. I think one is also from Google and so on. And I like the NumPy standard. So this is what I use mostly, but feel free to use anything you like. But important, stick to one convention. So this is now cell number 3. And now in cell number 4, we do something that is also being done in libraries or in good libraries with a proper CI/CD pipeline. You are testing your function. And here what we do is I just copy pasted the values from Wikipedia, the semi-major axis, the perihelion and the aphelion of the Neo Amor, Apollo, Aten and Atira. So the objects that gave the category the names. So with the designation number. And I put this here into the function. You see here, I don't write the first value of the list, the second, and so on. I use this asterisk here to give this list to give it as an input to the function that expects 3 variables. So of course the order is important. Yeah, you cannot switch these things here. If you would have used a dictionary, then this would be no problem. And of course, we expect that Amor is an Amor, Apollo is an Apollo, Aten is an Aten, and Atira is an Atira. So let's execute this cell, and no error is spawned. If I would now write something like other, then you see an assertion error is spawned in line 10. Other, there is an error. So of course, I did not expect that, but I just wanted to show you that also errors are being spawned. And this is how you could create, for example, a small test with PyTest and then put it into a directory with tests so that you can always, so if somebody else is changing something in this function, you know that the function still behaves properly. Let's move to the next cell. This is now, cell 4. This is now, I should maybe restart this so it's not too confusing. So 1, 2, 3, 4. Cell number 5, we would like to create a new column in our database. So the database looks like this. We have here the SQLite browser. We can go to browse data, and there we have the columns as I showed you in the beginning. And I would like to add a new column with the Neo classification or the Neo class or type. And for this, I create here a small new function, and it also expects the SQLite connection. So you have here the type is the SQLite 3 connection, the cursor, a table name, and column type, so that we can alter the table, add a column with a corresponding column type. So this is a generic function. You can use it for something else if you like. And if you call the function several times with the same values, an error would be spawned because you already created a column. So in the case of an error, of an operational error, nothing is being done. So yeah, the column already exists. Everything is fine. Everything is set. So now in cell 6, we can now create our column. So let's do it. We can go back to our SQLite database and refresh it. There you see the Neo class. Everything is null. And now we can fill the database now here in cell number 7. So what we do here, we select the name, which is the primary key or indicator of our database, the semi-major axis, the perihelion, the aphelion from the table main. We fetch the data and then we iterate through it and use the semi-major axis and so on. Here in this time, I use the list, not the asterisk. It's your, whatever you like. And then I call the function neo class, which is then a string. So the neo class is then the string with Aten, Apollo, Amor, or whatsoever. And then afterwards, I'm executing these command execute many, where I'm then transferring the dictionary into the database. At the end, then making a commit and closing the database. So let me just execute 7 and 8. And we can take a look now in the database, refresh it, and we see here now the different classes. So we can now have a look, for example, what were the numbers? If everything is all right. 1, 2, 2, 1 is Amor, so 1, 2, 2, 1. And we see here, first row, it's an Amor, perfect. Now the next one is 1862 should be a Apollo. And there we are, it's an Apollo, perfect. The Aten was, I think, 2062. It's also an Aten, nice. And now Atira is a very long designation number, so let me just copy paste it here. 163693. And it's an Atira, perfect. So now we can really work with the data in the future. We can also check if we have the category other. And yes, indeed, we have some of them. Maybe this is something we have to consider also next time. Why do we have others in there? So we could, for example, check the very first row, for example, and compare it with our definition. So the neo basics, here they are. Let's make it a little bit smaller. Can't get smaller than that. So we have the semi-major axis. Let's take a look. The semi-major axis is larger than 1. Okay, so potentially it can be an Apollo or an Aten. Perfect. And now the perihelion is 1.3001. Okay, this is really close to this definition. So probably if we would also extract the standard deviation, considering the error, it would still fit into this category, probably. So this may explain why this value is in there. We have also here very large values, so you see it could be. So let's have a look at this also next time. We have also here some very strange values for the absolute magnitude. Maybe these are objects where there was not a lot of observation time, so we don't know yet. Let's also have a look at Atira, for example. Atira, 28 values, asteroids. And yeah, so they are really smaller than 1 AU. Now this is really close, 0.58 AU, crazy. So yeah, we will work with this and visualize and do some statistics before we are computing their apparent brightness as seen from Earth. Okay, very well. This was a very short video today about the NEO classes, and I hope you learned a little bit. I will provide the links into the description. And until then, happy coding and see you next time.